Hello, I'm Kaeini. We are going to start the third lesson on differentiation. It is about the product rule, quotient rule, and turning points. Okay, now let us see. This is the third lesson we discussed is the product rule, quotient rule, and turning points. Now, what is the product rule? If you have two functions and your function is multiplication of the two functions, suppose u and v are two functions of x. Okay, the differentiation of the function y is equal to u times v. Therefore, now there is multiplication of two functions. So what we are going to do, we differentiate the first one and then multiply by the second and differentiate the second one and multiply by the first. You see dy by dx, derivative of this is equal to differentiation of this multiplied by this itself plus differentiation of this multiplied by this. Therefore, this is called product rule. Now let's see what are the examples we are having here. Now differentiation the function. Suppose the function is y equal to this bracket times this bracket. Now we want to differentiate this. So it's very simple. What you need to do is that dy by dx is equal to differentiate this one with 2x plus 4 and then multiply by this itself. Therefore, this comes here exactly same. X cubed plus x minus 2. And then plus, then differentiate the second one. This 3x squared plus 1, this derivative of this is 1, and then multiply by this one itself. So this is the derivative of this function. Okay, now we don't need to simplify this unless otherwise they have mentioned in the question. Now they are saying differentiate this, we have differentiated this. Suppose enough. Now let's go for the next function. Now this is 3x plus 2 to the power of 3 times x squared minus 3x. Remember that there is power 3 here, so you need to remember the chain rule also. Now, first of all, when you want to differentiate the first function, 3 comes down, reduce 1 from the power, and then multiply by derivative of inside. Therefore, you are going to get 3 times 3. One of these 3 is this power which is coming down, another 3 is derivative of this inside. Therefore, the power of 2, then multiply by this itself. And then plus, derivative of this will be 2x minus 3, 2 times by 3x plus 2 to the power of 3. Therefore, I hope you have understood how we have differentiated this. This 3 comes down, reduce 1 from the power, multiply by derivative after base, which is 3. Therefore, this is like that. Okay, now let's see what is the next question. Now he's asking us to find the equation of the tangent line to the curve. Okay, now we have the curve like that. Now let's see what's the point. At x equal to 0. Therefore, at x equal to 0, we need to differentiate this and find the other point of intersection of the curve and the tangent line. Okay, now let's see. Let's forget about the second part. The first part, we want to find equation of the tangent line to the curve. Now let us do that first. Now we know that we have to put x equal to 0 inside this function to get the y value. Therefore, if you put x equal to 0, negative 1 to the power of 2 is positive, times positive 1, times it will be negative 4 plus 3 is negative 1. Therefore, we have got the value of y. Therefore, we know what is our point. Now, differentiation of this is actually a product rule. Therefore, 2 comes down, reduce 1 from the power, multiplied by derivative of inside, which is 1, no need to write, times x minus 4. Plus derivative of this, which is 1, times x minus 1 is the power of 2. Okay, and the derivative of this will be 0. Therefore, this is differentiation of the function and the gradient of the curve and the tangent line at any point. Now, x is 0, just substitute 0 here. Let's see what we are going to get. At x equal to 0, dy by dx, this is 0. This is 0, therefore this negative 1 times this is 4. Therefore 2 times 4, this is actually 0, negative 1 to the power of 2 is 1. Therefore this is 8 plus 1, 9. Therefore the gradient of the tangent line is 9. The point is 0 and negative 1. Therefore easily you can write the equation of the tangent line. Now equation of the tangent line here it will be y minus negative 1 is equal to 9 times x minus 0. Just simplify that, you are going to get this. Okay, Now this is the equation of the tangent line. You need to find the point of intersection of this curve with this tangent line. We know already at x equal to 0 is one of the point of the intersection. We want to see where is there any other point of intersection or not. If there is, we want to find it out. Okay, now what we are going to do, for any point of intersection of the line and the curve, you have to put the two functions are equal. Therefore, we know that since the y coordinates of the 2 points are the same, you are putting this is equal to this. Therefore, you just find the point of intersection of the curve, the tangent line, just put this is equal to this. Now we have this equation. Now you have to simplify this, simplify the square this and multiply by this and that 3. Therefore, you are going to get this. Now, factorize x squared here. We are going to get x squared times x minus 6 equal to 0. Therefore, either x is equal to 0 or x equal to 6. This is because of the tangent line is always a repeated root. Therefore, x equal to 6 is the other answer which we were searching for. When x equal to 6, you can put it on the line or on the curve, doesn't matter. It's easier here to put. Therefore, x is equal to 6. 9 times 6 will be 54, minus 1 is 53. Therefore, this will be the other point of intersection of the curve and the tangent line. Okay. Now we are talking about the quotient rule. What is quotient rule? Now in this situation, we have again two functions, and the two functions, but it is divided. Therefore, y is equal to u divided by v. Now we want to differentiate this one. To differentiate this, we need to differentiate this first, multiplied by v minus derivative of this, multiplied by this, and then divided by v squared. Don't forget, you have to start from numerator and differentiate the numerator first here. Therefore, differentiate this first because it's negative. It is not same as multiplication. Multiplication doesn't matter which function you are starting because addition between them. Now, when there is subtraction, you should know which one you are subtracting from which one. Therefore, you make sure you are starting from here. Therefore, you are finding du by dx and then multiplied by v minus dv by dx multiplied by u divided by v squared. So this is the formula for differentiation of the quotient function. Okay, suppose y is equal to this. Now we want to find derivative. First, you have to find derivative of this numerator. Therefore, 2x plus 1 derivative is 2. Then multiply by denominator. Denominator is 3x minus 2. Now minus, find derivative of this, which is 3, times by 2x plus 1 divided by denominator to the power of 2. Just expand here, 6x minus 4. Expand here, you're getting minus 6 minus 3. Minus 6 and minus 6 cancel, is minus 7 divided by 3x minus 2 squared. Therefore, this is the derivative of this function. Okay, now let's see what is another example. Find the equation of the normal to the normal line to the curve, so and so. Therefore, this is a function. Therefore, we need to differentiate this. Now, how to differentiate this? First of all, derivative of this numerator, the derivative of numerator is 2. 2 times denominator, which is x squared plus 1, minus derivative of this is negative 2x, multiplied by this, then divide by this to the power of 2, denominator to the power of 2. Therefore, this is v to the power of 2. Now, we want to find the gradient of the tangent line or gradient of the curve. Just substitute 2 here. Therefore, first, I have simplified this. You can see at 2x squared minus 4x squared minus 2x squared minus 2x and plus 2. Anyhow, you simplify this, you are going to get this. Then now at x equal to 2, divided by this is equal to. Just substitute 2 here. 4 minus 8 minus 4 plus 2, which is minus 10 over 2 minus 2 over 5. This is the gradient of the tangent line to the curve. Now you need to find gradient of the normal to the curve. For that, just find the reciprocal of this and then put a negative. Therefore, this will be 5 over 2, but it will be positive. Okay? Negative times negative will be positive. This is the gradient of the normal line. Now you need to find the point. We will find the point. X is 2. Substitute here. 2 times 2 is 4 plus 1 is 5. Therefore, 2 squared is 2. 4 plus 1 is 5. Therefore, 5 over 5 is 1. Therefore, the point is this. Therefore, now it's very simple to write. Y minus y1, which is 1. M 5 over 2 times x minus 2. Therefore, this is the function. Now we can simplify that. You can get this is the answer for the equation of the normal to this curve. Okay, let's go for the next page and see what is the next page. No, turning point, maximum or minimum points. Now, look at this graph here. Now you can see the function here is decreasing, and then here goes increasing, and then decreasing and increasing. These points are called turning point or stationary points. And here also is another turning point or a stationary point. This also is another turning point or a stationary point. Therefore, there are three turning points. We call this local minimum, and this is called local maximum, and this is local minimum. Therefore, there are maximum, minimum points. When you're coming down from here, therefore, you know that the slope of the curve is negative, gradually goes to zero. At this point, the gradient is, or the slope is zero, and then it goes up positive, and goes up, gradually decreases to zero. And then again, here goes negative, and then goes here zero. Therefore, at the turning point, okay, at the turning point, sorry, now see whenever the function is decreasing, dy by dx is negative, and whenever the function is increasing, dy by dx is positive. At turning point, okay, the dy by dx is zero. Therefore, at turning point, dy by dx is zero. Therefore, whenever you want to find turning point of the function or stationary points of the function, you need to put dy by dx equal to zero. Therefore, first you have to find dy by dx, then solve the equation for this, and then substitute the value of x in the function to get the y values. Therefore, these are the three steps you need to do to find the turning points or a stationary point of the function. Now, find the turning points of the function so and so. Therefore, first we need to find dy by dx. dy by dx is very simple to find. You know that 3x squared minus 12x minus 12. Now put this one equal to 0. Therefore, you need to put this equal to 0. Therefore, now you have a quadratic equation to solve. It is easy. You can easily solve this equation. X equal to -1 and x equal to 4. Okay, now this is your x values. Therefore, you got the x values. Now you have to substitute here to get the y values. Okay, so turning points are, you put x equal to -1 here, just substitute inside this function, you are going to get 25. Therefore, this is one of the turning point, and the other one is put x equal to 4 inside this equation and simplify, you are getting y equal to -60. So these are the turning points of this function. Now, find turning points of the function. Okay, now for this, again, I need to differentiate this. To differentiate this, I need the quotient rule because this is the quotient. Okay, you can see that this, therefore, I need to use the quotient rule. Therefore, now for this, first, derivative of this is 2 times denominator will be x squared plus 1. Find derivative of this is minus 2x times this will be 2x divided by denominator to the power of 2. Now simplify here, 2x squared and minus 4x squared. Here you're getting minus 2x squared plus 2. Now we need to put dy by dx equal to 0. The turning point of dy by dx equal to 0. Therefore, this need to be equal to 0. A fraction or a quotient is equal to 0 whenever the numerator is equal to 0. Therefore, it doesn't matter what is this. This should be equal to 0. Therefore, minus 2x squared plus 2 is equal to 0. You can easily solve this. You're going to get x equal to 1 and x equal to minus 1. Just substitute here. When you are putting x equal to 1, you are going to get y equal to 1 or so. When you are putting x equal to -1, you are going to get x equal to -1 as well. So these are the points which are maximum and minimum of points of this function, or turning point or a stationary point of this function. Now, let us see second derivative and maximum or minimum point. Okay, now you look at this. Whenever you are having a curve like that, therefore you have got the minimum point. We know that df by dx or dy by dx doesn't matter, is equal to 0. But at this point, second derivative of the function is more than 0. It is more than 0. Therefore, when it is like that, it is a minimum point. If the second derivative is negative, therefore it's concave down, and then this will be a maximum point. Therefore, to determine a point is maximum or minimum, you need to find second derivative at that point. If that second derivative is positive, the point is minimum. If the second derivative is negative, the point is maximum. Now, Therefore, one of the methods of finding the nature of the turning point is to find the second derivative. Therefore, dy by dx equal to 0. If second derivative is more than 0, is a minimum point. If the second derivative is less than 0, is a maximum point. Now, we are not discussing about when the second derivative is equal to 0. There are conditions there, which is out of your syllabus now. Okay, now, we have this function. Now, we want to find turning points of this function and then determine their nature. Now, let us see. First, what we have to find dy by dx. We are finding dy by dx will be 3x squared plus 12x. Now, put it equal to 0. And when you are putting equal to 0, you are going to get this equal to 0. You can factorize 3x. You are going to get this. And then you can solve with x equal to 0. Then x equal to negative 4. X equal to 0, you can substitute here. You are getting y equal to negative 5. And then you are putting minus 4 here. You are going to get 27. Therefore, you have got 2 points. They are turning points or stationary points of this function. Now you want to do this. You want to know which one of them is maximum, which one of them is minimum. Okay, find the second derivative of this function, which is 6x plus 12. And then now substitute x equal to 0. When you substitute x equal is 12, 12 is more than 0. Since it is more than 0, this concave up. Therefore, it is minimum point. Then you are putting x equal to negative 4. You are going to get this is equal to negative 12. Just put negative 4 here. You're getting negative 24 plus 12 is negative 12, which is less than 0. Therefore, this is maximum point. Therefore, now we know we know that this at this point this is a minimum point and this is a maximum point. Anyhow, but this is the method which is we can do. There are other methods also. Change of sign of the dy by dx you can use, or if you know the continuity of the function, you can say the continuity of function. This is negative. This is less than this. Therefore, this is more. Therefore, this is maximum. This is minimum. Therefore, but then you have to discuss about the continuity of this function. This is hold whenever the function is continuous. Okay. Anyhow, this method of second derivative is very popular among the IGCSE maths paper. Okay, now let us go for the next example. I can put it here now. Now, the function y equal to x square root of x plus 3 is given. Find the stationary point of the function, determine its nature. Okay, now, first of all, we need to find dy by dx. We are finding dy by dx, therefore this will be a square root of, therefore derivative of this is 1 times this, and plus derivative of this will be half times this power of negative 1 times x. Therefore, you can see that I've used the product rule. Then I can use this in this format, then the common denominator. I am going to simplify this to this form. We know that I have to put dy by dx equal to 0, then I put dy by dx equal to 0, then I'm going to get x equal to negative 2. Substitute negative 2 here, I'm going to get y also equal to negative 2. Therefore, the point is negative 2, negative 2. Now I want to know this point is minimum or maximum point. Now I need to find the second derivative. Therefore, now I have this is the first derivative. Therefore, differentiate this. Derivative of this is 3 times this will be 6. Now differentiate this times this, you are going to get this value. Therefore, divide by this to power of 4, this to power of 2, which you are going to get this. Now substitute x equal to 1 inside this and see what you are going to get. X equal to 1, you are substituting here, you are getting 3 over 4, which is more than 0. So, sorry, I have substituted x equal to negative 2. Substitute x equal to negative 2, you are going to get this value, which is 3 over 4, which is more than 0. Therefore, this is a minimum point. Okay, thank you for watching. This was the third lesson. We are going to continue these lessons very soon.